Hey, polynomials are back. We talked about what makes a polynomial. Today, or last time, we looked about adding and subtracting polynomials. Today, we're going to look at how to multiply and divide polynomials. So, here we go. Let's just review what we know about multiplying. So first of all, let's take a monomial and multiply it by a binomial. So we're multiplying -5 times a minus 3. If you think of it as an area model, you know how to find area length times width. -5 times a is -5a. -5 times -3 is +15. So I really have -5a plus 15 as we organize those in standard form. Okay, so that's distributing. You've learned that before. -5 times a and -5 times -3. So pick a format that works for you. If you like to use the area model, go ahead and do that. If you think of distributing easier, then do that. So this next example, we have 4y to the third is a monomial. This time we're multiplying by a trinomial. So I put the three terms in there. Second term is 8y squared and +10. So I multiply. 4 times 7 is 28. Y to the third times y to the sixth is y to the ninth. We add exponents when we multiply. 4y to the third times 8y squared is 32y to the fifth. And 4y to the third times 10 is 40y to the third. And then I can just combine all those. 28y to the ninth plus 32y to the fifth plus 40y to the third. So why don't you try this next example? We're multiplying a monomial times 1, 2, 3, 4, 5. A polynomial with 5 terms. So pause the video and start it once you want ready to see this solution. Okay, so once I distribute, I get -20x to the fifth minus 10x to the fourth plus 15x to the third minus 10x squared y minus 20x squared. Always pay attention to those negatives there and when we're multiplying. Let's multiply binomials together. Same process. We can take what we know about the area model. 18 times 17. I'm sure you can do that in your head. You know your mental math pretty well. I'm going to switch it up on you. So if you have a calculator handy, why don't you do 18 times 17 quick? I can't find my calculator. Why don't you do it? Tell me. Okay, good. Thank you for calculating that. 18 times 17. I can break 18 into 10 plus 8 and 17 into 10 plus 7. Is that right? Yes, it is. Thank you. So now what I'm going to do is break that into my area and say 10 plus 8 makes 18, and 10 plus 7 gives me 17. If you disagree, let me know right now. So now I'm going to calculate the area of these 4 sections and add those all up to get my total. So 10 times 10 is 100. 10 times 8, this part is 80. 10 times 7, this section is 70. Final section is 7 times 8, 56. So if I add these 4 sections together, it gives me the total area of 18 times 17. 100 plus 80 is 180, plus 70 is 250, plus 56 is 306. And that's what you calculated earlier of 18 times 17. So it doesn't matter which way we go. We can multiply 18 times 17, or we can multiply each of the parts together. So what we're doing is we are distributing, and as we distribute, I multiply the 10 times the first 10, and the 10 times the 7, so 10 times the 10, 10 times the 7, and then I multiplied my 8 times the 10, and then my 8 times my 7, and I multiplied all combinations. It's really using the distributive property. So we can do the same thing with another binomial, x squared minus 8 and x to the fifth minus 7. So x squared minus 8 and x to the fifth minus 7. We just multiply each of the sections together. X squared times x to the fifth is x to the seventh. Minus 8 times x to the fifth is minus 8x to the fifth. X squared times negative 7 is negative 7x squared. And finally, negative 8 times negative 7 is positive 56. So when I rewrite this out, I'm going to go in order, decreasing order. So x to the seventh is my largest term. Then I have negative 8x to the fifth. Fifth degree is next. And then I have negative 7x squared. You see, I don't have any terms I can combine here. So I just list them all out in order, plus 56. So if the area model works for you, otherwise think about it as distributing. X to the seventh, x squared times negative 7 is negative 7x squared. And negative 8 times x to the fifth. And then I have negative 8 times negative 7. Then I need to switch these around in order to put them in proper standard order. So we don't need to get scared away once we see a trinomial multiplied by a binomial. I can just write it out as the area model. A squared plus 3a and minus 4 times 2a plus 3. And I know that the a squared times 2a is 2a cubed. 3a times 2a is 6a squared. Minus 4 times 2a is minus 8a. A squared times 3 is 3a squared. 3a times 3 is 9a. Negative 4 times 3 is negative 12. And then at this point, I would need to look for like terms, starting with my largest degree of 2a to the third. Then we look for a squared. So I have 6a squared and 3a squared is 9a squared. When I combine those, then degree 1, 9a and minus 8a is positive 1a, just plus a, and then minus 12. So you can see how that area model lays it all out very nicely for you. Otherwise, use distributive property, and we're going to distribute that a squared to both terms in the binomial. And then we're going to take and distribute the next one over. 3a times 2a is plus 6a. 3a times 3 is plus 9a. And we'll finish up by distributing the negative 4. Minus 8a, and then minus 12. And then it's just a matter of combining like terms. So we'd have to take a look at what terms we have. The 2a to the third plus 3a squared. Did I forget a squared in there somewhere? Yeah, 3a times 2a should be 6a squared. So those combine. And my 9a and my minus 8a combines. Minus 12. So we're applying what we did with adding and subtracting polynomials the other day. All right, so now we have x plus 4 squared. Well, you know what exponents mean. You learned that last unit. It means whatever's in there gets multiplied by itself twice. So x plus 4 times x plus 4. If I want, I can create my area model. X is the first term, 4 is the second term. X is the first term, 4 is the second term. X squared, 4x, and 16. X squared, 4x and 4x is 8x, and I have 16. Okay, I would like you to try the next two. Pause the video, multiply those together, and then we'll see if we can find a pattern to these. All right, do you see a pattern? We take a look. When we do x plus 5 squared, we get x squared plus 10x plus 25. 2x minus 7 squared, we get 4x squared minus 28x plus 49. Well, I noticed that when I do x, it's x squared. X is x squared. 2x became 4x squared. 4 squared is 16, 5 squared is 25, negative 7 squared is 49. Then I see this middle term is doubled. So 4 times x times 2, 5 times x times 2. Negative 7 times 2x is negative 14x, doubled. It's negative 28x because I take those twice. So we call this the square of a binomial. Okay, so the square of a binomial has a pattern to it. So let's say we have a plus b, we'll call it, any binomial. So a plus b, and we square it. Well, what do we see happens? The first term gets squared. The last term gets squared. And we double and multiply the other terms together. And if we have a minus b squared, same thing. Square the first term, square the last term, and multiply both terms and double them in between. So that's a pattern that works for those binomials. Here we have what's known as a difference of squares, or rather a sum and difference pattern. So in the sum and difference, I'd like you to take a look, multiply these out, and see what kind of pattern you find when we have the sum of two terms and the difference of those exact two terms. So what happens when we multiply those two together? So try those out and see what kind of pattern results. So notice when we do x plus 4 times x minus 4, we get x squared positive 4x minus 4x and negative 16. So the x terms cancel out and we're just left with x squared minus 16. Same thing happened in the next one, x squared minus 25. And in the final case as well, x squared minus 25 y squared. So notice the first terms get multiplied together, the last terms get multiplied together, and the middle terms get canceled out. So the sum and difference pattern, we have a plus b times a minus b. We end up with a squared minus b squared. Give you a chance to write that information down into your notes, that pattern that we have here. If you need to copy this down, we talked about this already, so pause the video and copy down the information that you need. And finally, we'll take a look at dividing a polynomial by a monomial. It's kind of the reverse of what we've been doing, reverse distributive property. So we're basically just taking 6x squared plus 12x to the third, and we're saying that's our area model. So we have two terms, 6x squared and 12x to the third. And we're dividing by negative 6x squared. So we have to figure out what would the other side be. So 6x squared divided by negative 6x squared is negative 1. And then 12x to the third divided by negative 6x squared is negative 2x. So I'd finish with negative 1 minus 2x, put it in correct order once we're done dividing it. Negative 2x minus 1. Okay, so that's kind of using that area model that I've shown you. The other way we can do is we can think of this as dividing. So I have to take 6x squared divided by negative 6x squared, and I have 12x to the third divided by negative 6x squared. And we divide it that way. So in that case, we get 6x squared divided by negative 6x squared. Coefficients give us negative 1, and the x squareds cancel out to give us 1. X to the third over x squared, we have 1x left over, and 12 divided by negative 6 is negative 2. So negative 2x, which we then can rewrite as, well, there we go, negative 2x minus 1. Just switch the order around. Why don't you try the next example? Pause the video, start it when you're ready to see the solution. So a to the fifth x divided by a squared x is a to the third. X's cancel out. Negative 2a to the fourth x squared. We have negative 2. a squared x. The final term, a to the third, x to the third, divided by a squared x gives us ax. Okay, so dividing is just reverse distribution. Just remember to divide every term in the polynomial by each of them by the monomial on the bottom. So we've added what we know about working with polynomials. We know how to divide and multiply polynomials of various types all together. So we'll do some more practice with that in our assignment.